Hello everyone and welcome to STEM School. In today's video we'll be looking at the rules of indices exam questions. In my part 1 video I went over all the different rules in great detail, so check that video out for more clarity. So today I've got plenty of exam questions for all the different types you could be hit with in exam. So let's get started with some basic numerical calculations. We have 2 to the power of 5 multiplied by 2 cubed. So we can appreciate that we have the same base of 2 here. This means that we can use this rule when you're multiplying and all you have to do is add the powers. Okay, so let's do that. So it'll be 2 to the power of 5 plus 3, which will be 2 to the power of 8. Now this is a non-calculator paper, so you just have to manually write it out to work out the answer. So it'll be times 2 times 2 times 2 times 2 times 2. Okay, so let's work this out. So it'll be 2 times 2 is 4, 8, 16, 32, 64, 128, 256. Okay, now I just did that in my head, right? But realistically in the exam you just have to do some arithmetic, some calculations to the side. So if you got stuck at this step, for example, 128 multiplied by 2, just work it out like this. So 2 times 8 is 16, 2 times 2 is 4, plus the 1 is 5, 2 times 1 is 2. Okay, so just do loads of these calculations, and it's a bit tedious, I know, but that's the easiest way to work it out. Now let's go into this second example. We're asked to find the cubic root of 64 times 1000. It's written in a strange form, but this is actually hinting towards a good way to figure this out, because they've separated it into 64 times 1000 instead of just saying 64,000. So when we're working out the cubic root, what we're saying is that something times something times something is equal to 64 times 1000. So whatever is inside this root. So we can actually rewrite this using this fractional power rule. Okay, so this is a good way to work it out. This is the same as saying 64 multiplied by 1000 all to the power of a third. Okay, so I've just used this rule of fractional powers. Just imagine a 1 there, you don't normally write the 1. So this power on the outside is affecting everything inside this bracket, okay? So this is the same as saying 64 to the power of a third multiplied by 1000 to the power of a third. And what we can do is work each of these out individually. So this is the same as saying something times something times something is equal to 64. So it's a non-calculator paper, you just have to manually test different numbers to work it out. And what you'll find is that 4 times 4 times 4 is equal to 64. So 4 is a magic number. Now let's do the same with 1000. So it's something times something times something is equal to 1000. Okay, so just test different numbers, but clearly it will be 10 times 10 times 10 is equal to 1000. Okay, so 10 is a magic number here. So we can sub that in, so it will be 64 to the power of a third is the same as 4. Then 1000 to the power of a third is the same as 10. 4 times 10. So the final answer will simply be 40. And there we have it. Alright, so let's move on to a calculation involving BODMAS, or you might have seen it written as BIDMAS. So BODMAS is essentially the order in which you do all the different operations like division, multiplication, addition, etc, etc. So we have a question here which is 3a minus a multiplied by 4a plus 2a. So clearly we have to use BODMAS here, as it's totally different operators here. So what we have to do is we have to use multiplication first. So I'm going to put it in brackets to separate it, so we know we have to do that first, okay? So here we've got two like bases, so we have a times a, right? So we just have to add the powers. Just imagine a floating 1 there. You don't normally write the 1, but it's there, okay? So it'll be 3a minus, so a times 4a will just be 4a squared. So the 2 comes from 1 plus 1. Then we have plus 2a on the end there. Now let's tidy everything up, so we have 3a plus 2a, so that'll be 5a, then 4a squared. Okay, so that's the final answer. Alright, so let's do some questions which will require us to use multiple rules in the same question, okay? So this first question here, we've got root 3 all squared multiplied by root 2 all squared. So the easiest way to deal with this is by turning this square root into a fractional power using this rule here. So what you should appreciate is that when you have root 2, something like that, you imagine a 2 there and a 1. Okay, so since square root is quite a common operation, you don't normally write it. So using this rule, we can say that root 3 is the same as writing 3 to the power of a half, right? And then we're going to square everything. Okay, let's do that for the root 2 as well. It will be 2 to the power of a half, all squared. Now this second rule will involve power of a power rule. So you multiply the power inside the bracket by the power outside the bracket. So it'll be 3 times to the power of a half times 2, which is 1. Okay, now 2 to the power of a half, so a half times 2, you multiply the powers, so that will just be 2 to the power of 1. Okay, so 3 times 2 is simply 6. Okay, now let's do this second question here. We have n squared all cubed multiplied by n to the power of minus 10. So let's deal with this first term first. So we've got n to the power of 2 all cubed. So we just multiply the power inside to the power outside. So that will be n to the power 2 times 3, which is 6, multiplied by n to the power of minus 10. So here we've got a common base of n. So we can just add the powers using this rule here. So this will be n to the power of 6 plus minus 10. Okay? And that will just be n to the power of minus 4. Now it isn't good practice to leave answers in a negative power. So what we have to do here is use the negative power rule. So we have to take the reciprocal. So just think 1 over, when you hear the word reciprocal, 1 over n, and it'll be a positive power in the denominator. Okay? So let's go on to this third question here. We've got root 6 squared plus 8 squared is equal to the cubic root of 125a cubed. Okay, so let's deal with each side one at a time. So 6 squared is 36 plus 8 squared is 64. Okay, and that is equal to, so this cubic root, so this is the same as saying 125a cubed all to the power of a third. So you're using the fractional power rule here. So 36 plus 64 is 100. Now square root of 100 is 10. Okay, so there's different ways to work the right hand side it. What we can appreciate is that this power affects everything inside the bracket. So this is the same as writing 125 to the power of a third multiplied by a to the power of 3, so 3 times a third. So you have to multiply the power, so it's power of a power rule that we're using. So it'll be 10 is equal to, so let's work this out to the side. So when you have a cubic root like this or a third power like this, it's the same as saying something times something times something is equal to 125. So you just have to manually work it out, and what you'll find is that 5 times 5 times 5 is equal to 125. So the magic number here is 5. So 125 to the power of a third is 5, multiplied by a to the power of 3 times a third will just be a to the power of 1. And you don't normally have to write the 1. So 10 is equal to 5a. And here we can figure out what a is. So a is equal to 2 as the final answer. And finally, we're going to do some questions for fractions raised to a negative power. These are a little bit harder, so let's have a crack at this one. We've got a third all to the power of negative 3. So whenever you see the power of a negative power, just have to think the reciprocal. You have to use this rule where you take the reciprocal, so we have a positive power, because we like dealing with positive powers. So when you take the reciprocal, you think 1 over, so it'll be 1 over 3 over 4. And everything is to the power of 3, so we have a positive 3 on the end there. Now this 3, the power of 3 affects everything in the bracket. So when you have a fraction like this, it will just be this. So it will be 3 cubed all over 4 cubed, okay? So we just work each of these out. So it'll be 1 all over, 3 cubed is 27, all over 64, okay? Now, when you get this kind of scenario here where you have 1 all over a fraction, you just have to think, I can flip this, so the answer will be 64 over 27, okay? But mathematically what you're doing is, so we have 1 over 27 divided by 64, right? Mathematically what you're doing is you're timesing the top by the flipped, right? So you have 64 over 27, and then you multiply the bottom by 64 by 27, okay? So when you do this, the bottom will just turn in, will cancel out, okay? So the numerator will just be 64 over 27. So that's mathematically what you're doing. Now, let's do this last example here. We've got 27 over 8, all to the power of negative 2/3, okay? Bit of a nasty example here, but it's very similar to the previous one. So we have a negative power. Let's take the reciprocal using this rule here. So we have 1 all over 27 over 8. Everything is to the power of positive 2 over 3. Okay? So let's do that. So here we can say that 1 is over 27 over 8. So using this fractional power rule, we can do the other way around. So this is the same as saying, so the 3 will go here, and then the 2 will go here, okay? So this is another way to figure this out. So when you get this scenario, we'll deal with this part first in the circle, right? And then when you get this answer, we're going to affect the power on the outside, which is the 2 here, okay? So I wanted to do this example because it shows a good technique, right? So when you have a cubic root, right, that's the same as this. As I've said before, something times something times something is equal to 27 over 8. But in this example, we have a fraction. So what we can actually say is a over b multiplied by a over b multiplied by a over b, so it's 3 times, right, is equal to 27 over 8. And what we can do is deal with the numerator and denominator separately, okay? So something times something times something is equal to 27, right? So the answer to that will be 3. Okay, so 3 times 3 times 3 is equal to 27. Okay, now let's deal with the denominator. So we have b times b times b is equal to 8. So 2 times 2 times 2 is equal to 8, right? So 3 over 2 is a magic fraction that we're dealing with here. So that's just a good technique I wanted to show you guys, right? So let's sub that back in. What we have here is 1 all over 3 over 2 all squared, okay? So the squared comes from the outer part here. So now we're going to deal with this power. So this is the same as saying 1 over 3 squared all over 2 squared, right? So 1 over 3 squared is 9, 2 squared is 4. Okay, using the same process as before, we can flip this, okay, just flip it. So the final answer will be 4 over 9. And there we have it. Alright, so hopefully you guys found this video helpful, and if so, please do like and subscribe, and I'll see you in my next video as we tackle scientific notation.